Hey y'all, welcome back to the lab. In this video, we're going to be discussing review your AI's code, a simple process for building more robust systems faster with AI. So I've been using AI to help me code for the past several months and have noticed a pattern that seems to set those who use it effectively apart from those who use it haphazardly. The pattern seems to be that those who review their AI's code, understand it, and change it accordingly build more robust systems faster than those who don't. AI is good, but it's not great. AI-generated code and references are incredibly good, but they're not perfect. The reason they're not perfect can be manyfold. Their training data is different, it might be off, it might be outdated, it might just be different from the knowledge that's in your head. They don't hold the whole code base in context, at least not yet. And even the ones that do kind of cost a lot, so, there's a trade-off there. They don't know the best practices of your org or your subjective taste. And perhaps you just haven't given them enough context to actually do what you wanted, the way you wanted. You told them to go make a thing, but you didn't tell them what color or what your principles are or what you're optimizing for or the reason that you're doing this. And so they build the thing, just not the way that, you actually expected it to be built. And so every time you do a generation, it might be just a little bit off. Misalignments compound. And so this means that even good generations are off by some percent from the ideal. Maybe it's just 1%, or maybe it's 10%, which doesn't seem like that much, but the problem is that these misalignments compound. It might not be in 2 or 3 generations from now, but give it 10 or 20, and those small misalignments and what we hoped to achieve have now turned into large misalignments in how the system has grown. Just for some examples, doing 99% twice leads to basically 98%, 99% 10 times leads to 90%, 99% 100 times leads to 36%. So these very small differences compound. Another way of thinking about this is like if you are flying around the world, or maybe you're flying, let's say, from New York to England, but you're like, a few degrees off, you could end up in a totally different country, hundreds, thousands of miles away, because that tiny misalignment compounded over a large distance. And in my mind, this is often why vibe coding projects turn into big balls of mud after a few days or weeks. They start out working, you get your little website up, it's like pretty cool, it's got some nice colors on it, you can click the buttons, you can go get a checkout, it's all great. But as you layer those small misalignments onto each other, even the AI starts to get confused about what's going on. And it's going to start duplicating code everywhere, it's going to start implementing things in a slightly wrong fashion. Things are going to start to break, and it's just going to slowly break down and stop working. And these misalignments aren't just from AI. These happen in software engineering teams too. But the key is the speed at which the system's trajectory goes off course with AI. And I'll say that this is mostly because effective software engineering teams have processes in place to regularly reconcile these misalignments. Ineffective software engineering teams, I think, don't use code reviews, and they don't have a way to have this alignment reconciliation. Some places do pair programming, which I personally don't like, but that's another way to do this as well. But if you don't do that, then someone's going to go off on their own. They're going to go build something to what they believe is correct. But because they've never checked it against, other engineers' understanding of this, they're going to come back and it's going to be like wildly different than what probably the org wanted or needed. And now it's going to require some weird integrations to actually get it working with everything, or they're going to have to scrap the project and redo it. And so code reviews are simple, effective tools for reconciling misalignment. The way that we resolve this in software engineering teams at scale is RFCs, or requests for comments, or sometimes called project specs. There's different ways of calling this. And we do this for large pieces of work so that we can, get everyone on the same page theoretically, conceptually, and before we actually spend the time to actually code this thing. And then code reviews with peers for each change to reconcile those small percent differences at implementation time. Because, when you go from concept to actual implementation, there's, again, often some change in what's actually happening. This is like the game of telephone, basically. And so having that final barrier right before the code turns into part of the system is super, super valuable and important. And I've actually seen this online a lot, that some people are against code reviews as they say it like slows people down. But I think they're one of the most effective practices we have for improving system quality and knowledge transfer. I also think this view of slowing down is really short-sighted, as it's a small cost short-term to avoid huge costs long-term if you need to fix a misalignment later, because usually things have been built on this misalignment, so now I got to go migrate everything off of it in order to fix the core root cause, and this is going to take like a whole team like 6 months to change, when if we just caught it at code review, it might take another day or two for that person to go back and change it, but it's not 6 months. I think there's a few benefits to these code reviews, right? The code is implemented so we can talk about specifics, not nebulous theory. And so, the RFCs will do the overarching kind of systems and stuff. But once you go down to implementation, you might find out that like, oh, this doesn't actually work, or, oh, the way that they were thinking about this is actually different than the way that I was thinking about this when we were talking about just the concepts with the system diagram. You can then course correct early before the code reaches prod and additional systems are built on top of it. Again, this is like spending an hour or a day or two to actually fix the problem before you built everything on top of it and need like a 6 months migration just to get this thing changed. You can point out new different ways of doing things that people may not have seen before. I think this is mostly for humans, but I think also AI code reviewers can give you ideas on this for just ways to make code better. I think reading code can often help this if you're reading a lot of other people's code, but often the way that you learn is by writing code and then by getting people's feedback and changing it yourself. I think this is one of the best ways to improve your code craft. Also think reviews can serve as long-lasting forms of documentation for what we did, why we did it that way, and alternatives considered, because you can use like a git blame. It will link the PR. You can go look at the PR. It'll link the JIRAs or the documentation or the tasks or whatever it is. And so you can go back and kind of trace back to the business decision and understand all of that stuff, which is especially useful when you come in like a year or two later and you're like, why was it built this way? Am I going to break things? Stuff like that. And finally, it spreads the knowledge about how things are implemented, so more people are aware and can build off that new context. And I talk about this in some of my other posts where one of the ways I think vibe coding goes wrong is because you let the AI drive the whole thing. And so the AI is the only one building context, but that context is ephemeral, right? It's going to lose all that context when it goes out the context window, when you spin up a new AI. And so all of that knowledge built up of how the system works is just like gone. But, in order for a system to grow, it needs a good, or grow in a good way, it needs a good gardener or a good shepherd to understand the context of what it's trying to do, how it's built, how a new part of the system will affect the larger whole. And so the way that code reviews help this is by getting other people on the team to understand this so that when they build things, it makes sense with respect to the whole, with the way that we're actually moving this system and growing it, which keeps misalignments from happening like in various parts of the tree. We keep them more consistent across the areas of the system. But if it's just you and AI, and the AI is not remembering this, and you don't know how your system is being built because you're just like, tab, everything, then nobody's actually shepherding this system into the right direction. And so it's just going to grow into like a wild mess. Okay, so best practices for AI code reviews. So hopefully we're aligned by now that AI code is good, but not great. Misalignments compound, and code reviews are an effective tool for reconciling misalignments. Here I want to share a few practices that I've found work well for turning this AI code into a production-ready package. The first is to review your AI's code. Review it like you would another engineer's. Understand it, ask questions, run the tests, and make changes to better align with the goal. This does take time, but ideally, the time that you saved, from not having to code all of it should more than make up for the amount of time it takes you to review this code. A new practice I've started doing that I really like is to ask another AI to review the code. It doesn't need to be like a different model even, it just needs to be like a clean context AI, so it's not just like repeating back what it did to you. And this is useful because each AI comes in with a different perspective based on their training data and the context you provide. You can give it different prompts. You can just erase the context from what it built so that it's just like a new set of eyes. And this means that they can serve as, another pair of eyes to offer suggestions for things to change. And I have 2 prompts that I currently like to use. The first is just to ask for the top 3 things that I could or should change about a PR to make it better. And this kind of keeps it focused to just the main things, because there's infinite things you can change about a PR, but I really just want to know the biggest things it thinks exist. I will say that usually only 1 or 2 of these things are actually useful because it doesn't understand the broader context, which we'll talk about in a minute. But still, usually at least one of them I'm like, oh, think about that. That could be a good change. And then the other one is just for specific reviews on a specific area of code, the same way that you'd call it out in a review for a human. I think AI first pass is great because it might just have the suggestion you need to kind of get unblocked on that area. The next thing you should do after these reviews and reviewing yourself is to clean up the PR and get it to a state where you would approve it. You should never publish AI-generated code for review before reviewing it yourself. That's basically as bad as writing code and making someone review it before you've run the tests. Like if you haven't run the tests, it's probably going to break. And yeah, I know we have like PR CI now that usually runs tests, but it's kind of ridiculous. It's like the person's going to see the tests are broken and then be like, can you fix the tests? Like I don't even have any confidence this works. Like why would I review this code? And I honestly think it might be even worse, as AI is pretty good at generating code that that looks like it makes sense. And then writing tests that inconspicuously use fake data to pass. So a reviewer might see it, it'll give it a glance, be like, I think this makes sense, and then just give it a look good to me, and then you land broken code. And I think AI does this a lot. It thinks it's helping sometimes because it's like, oh, I'll make the test pass. You just want to get this coded. But it's like, no, if it's running on this fake data that like isn't actually running through the system, it's like not that useful. And I also think it's a waste of time for you and the reviewer, as there's almost always something obvious that should be improved, whether it's your code or AI's code. And so you waste a whole cycle of back and forth if you're just pushing code that's like, hey, like you can't land it like this, like fix this thing, before they can actually get to the deeper things about like how the logic functions. And so I think you should first improve the code until it's good enough that you would have approved it coming from someone else before submitting it to another human to look at. And I do think you should be doing this even on code you've written yourself. This doesn't just apply to AI code, it applies to your code. This is similar to writing. You should edit your work before you force someone else to read it. Like, why would you give someone a rough draft when you know it's not that good? You know that there's stupid things in there that like should be removed. Like, just do a one pass on it before you waste someone else's time looking at it. And I think this is a pet peeve of mine, which might honestly be why I ended up writing this post in the first place. But if you're shipping code with like very obvious defects, to me, it looks like you didn't care enough to actually go and find this. And because these things are so easy to find, it almost looks like you either have like a huge skill issue and maybe shouldn't be doing this, or you're just kind of negligent. And both of those things are just like bad. And like, obviously there's going to be bugs in PRs, and that's why we do code reviews. There's going to be misalignments, but like if it's like very clear that this is awful and you didn't even like give it a look, that looks like really bad on you. And that's probably something that I will bring up in reviews, especially if this is a pattern, because that's just like not good for the org. It's a waste of time and inefficient for basically everyone. And so the practice that I like to tell engineers to do, and that I do myself, is even when I write my own code and I pass the test and I've like done everything, I put it up for review in a draft state, and then I go through the draft and review it like in the UI, just like I would be editing someone else's things. And you'll notice that you'll catch so many things that way that maybe you missed in the editor, whether it's like random comments or things just like look kind of weird or too complicated that you can like clean up, and do a first pass that way before you ship it off to anyone else, because shipping off to anyone else is just going to take longer than if you just did it yourself. Same thing with editing. There's like an editing form where basically if you read it on the screen or in your editor, you're not going to see the mistakes, but if you print it off, or what I do is I actually publish my blog post to my website and then read through those before I actually publish it externally, and you're just going to catch a lot more things that way. And it's only going to take you another 10 minutes or so. So well worth the extra cost. And then, of course, finally, after you've made those edits, you've reviewed it yourself, you've gotten an extra pair of eyes from AI, you're going to put it up for human review. And so if you're working on a team at a company, you should still get a human review. Humans with domain knowledge are still going to far outperform AIs on reviews for the simple fact that we can hold more context and memory. We have more knowledge about the technologies, not always, depends on how familiar you are with it, but about the company and about the business case that this code is meant to solve for. And I think AI can be way more in depth in some ways. I mean, it gets things wrong at depth, but I think it can be more in depth about some things, especially cases where you aren't that knowledgeable, but it has access to core docs to understand. But I think where it falls short is the combination of these things that humans can still keep in context, but the AI just can't, because its context window is too small. It gets too distracted. And so when we're making changes to a system that need to fit a business case, that need to keep in mind, other projects that are going around on the company, AI just cannot do that right now. And so humans are just a far better reviewer for those things. And so I think, this human review is the ultimate alignment reconciliation. So while it is expensive, time and effort wise, it is well worth the returns. And also note that human reviews are usually required for both practical and compliance reasons. And so I think at most companies, you can't even get around this really. But I do think it's worth calling out explicitly that there are other reasons beyond just leadership telling you to do this, that code reviews, especially human code reviews, are a very, very good idea. Now, if you're just working on personal side projects, then you can probably skip this step. I don't ask a human code reviewer to review changes to my side projects. That'd be crazy. But I do think the AI code reviewers are pretty easy to set up and quite fast and useful. next. So yeah, review your AI's code. Your system will be better for it, and you'll likely improve as an engineer from it. Plus, I find the more active approach to using AI is more fulfilling. We're building together. I'm not just pressing the slot machine button over and over. And that's kind of my view of like a lot of these vibe coders. Like, I think they often start off with like, oh, I want this, and then they're like actively coding, and then they kind of get used to it, and then they're literally just sitting there like tapping the tab button, and it looks like those people who just go to Vegas and they sit at the slot machines and they literally just like tap like this, and that's just kind of crazy. I don't know how that's fun, really. So anyway, if you like this post, you might also like I vibe coded a C# library with Claude Code, and here's 6 things I learned. Might also be interested in start vibe coding, start power coding, perhaps better aptly named as vibe engineering, how to write quality software faster with agentic AI, and finally, how to checkpoint code projects with AI agents, save your work, keep projects on track, and reduce rework. And really, this is how you should avoid wasting like a whole week's worth of work, and then it like drops the database, and then you're like, oh no, what do I do? Everyone should be checkpointing their code. Anyway, that's it for this video. Thanks for watching.